Okay, so a continuation of our three polynomials, I want to finish it off talking about division of polynomials. Now I chose to put this in a separate video because addition of polynomials and subtraction of polynomials, like we said, it's basically just combining like terms. Multiplication of polynomials, people tend to understand that pretty well and can work their way through it without any difficulties. Now, division of polynomials gets into that thing called long division. And I know that many math students, many students in general, do not like long division. And then it gets even more confusing when you're dealing with variables in your divisions. So that's why I'm breaking this off into its own little thing. Because we're going to divide polynomials into other polynomials. And we're going to use it using the exact same methods that we use for division. So let's look at how we divide using long division and what the process is. So let's say I have 376 divided by 5. 376 divided by 5. Well, what do? We say, how many times does 5 go into 3? It doesn't. Okay, how many times does 5 go into 37? It goes in 7 times, 7 times 5, right? So now we take this and multiply it by the divisor. 7 times 5 is 35. And then we subtract. 37 minus 35 is 2. And then we bring down the next value. So bring down the 6. You get 26. How many times does 5 go into 26? It goes in 5 times. 5 times 5 is 25. We subtract and we get 1. And we can say with a remainder of 1, right? That's a remainder of 1 because we don't treat it like we do decimals, because with polynomials we're not going to be able to treat it like decimals. But we can deal with it like we deal with remainders and fractions. So this is really plus 1 over 5, right? And 1/5. This 1 is waiting to be divided by that 5. So that's 75 and means plus, right? 75 and 1/5. This is the same method that we're going to use for dealing with polynomials. We're going to see how many times this goes into the first part of this. Put that up here, multiply, subtract, see how many times it goes into the next part, multiply, subtract, see how many times it goes in the next part, etc., until we run out of things to drop down. And then whatever our remainder is, we're going to put it over the divisor. So there's our process. So let's take a look at one. I'm going to grab one that I already have on hand. So what if we have 8a cubed plus 2a squared plus a plus 3 divided by 4a plus 3. Okay, so we've got that in place. So the first thing we're going to do is we're going to turn it into a division problem where we can do long division, right? So we're going to go 8a cubed plus 2a squared plus a plus 3 divided by 4a plus 3. Now, I know you're looking at this and going, that does not look pretty, Mr. Davis, and I understand that. The nice thing about dealing with division of polynomials is we really deal with the first term only. So we're only dealing with one term at a time as we're figuring out if we can divide it in out. So we're looking at this 4a and this 8a cubed. And we're saying, how many times does 4a go into 8a cubed? Or another way to look at it is, what do we need to multiply 4a by to get 8a cubed? Well, to turn a 4 into an 8, we need to multiply by 2. I'm just going to put that there for a moment. To turn an a into a cubed, we need to multiply by a squared, right? So 4 times 2 is 8. A times a squared is a cubed. So we're looking at, what do we need to multiply this term by to get that term? So we come out with this 2a squared, So I'm going to come over to the squared column. Notice that we've got cubed, squared to the first constant term. We want to keep that process in line, so we're going to put, since it's going to be 2a squared, we're going to put that squared over the squared. We're going to keep them in line. Now we're going to take this value, that 2a squared, and we're going to multiply it by 4a plus 3. So 2a squared times 4a gives us 8a cubed, and it should, because that's why we chose 2a squared, because that's what it needed to get that, which is going to cause it to cancel out when we subtract. And we get 2a squared plus times 3 gives me 6a squared. So remember, the next step was to subtract. I put my subtraction out of ways because it helps me to remember I'm subtracting the whole thing. Sometimes people put it right there and they end up subtracting 8a cubed and then adding the 6a squared. Whereas this is telling me I need to subtract each of those terms. So 8a cubed minus 8a cubed, 0, so I'm not going to put anything in there. Just like when I was subtracting for my long division, I didn't put a 0 in for the first part, I just put down the number that it subtracted out to. And then I have 2a squared minus 6a squared gives me negative 4a squared. And this is where people are going to make their mistake, most likely, is in this subtraction part, they're going to get a sign wrong. We've got 2a squared minus 6a squared gives us negative 4a squared. And then we bring down the next term, plus a. Now we say, how many times does 4a go into negative 4a squared, or what do I need to multiply 4a by to get negative 4a squared? And I can see that I need a negative 1a. 4 times negative 1 gives me negative 4, a times a gives me a squared, so minus a. Now I get to multiply through. Negative a times 4a gives me negative 4a squared. Negative a times 3 gives me negative 3a. Now again, I put my subtraction over there, so I'm going to subtract negative 4a squared minus a negative 4a squared is the same as negative 4a squared plus 4a squared. Cancels out 0. Please make sure you do that step. Make sure you do that because it's not uncommon for people to say, well, it's going to cancel out, and they don't bother checking, and they did something wrong, they put the sign wrong, and it didn't really cancel out. So that canceled out, so we have a minus negative 3a. Well, a minus negative 3a is the same as a plus positive 3a, so a plus 3a is 4a. And we bring down the next term, plus 3. Now you might be able to see right now what's going to happen. 4a goes into 4a once. 1 times 4a is 4a. 1 times 3 is 3. Remember, we're going to subtract that. 4a minus 4a gives you 0. 3 minus 3 gives you 0. So we cleaned up and we're done. So 8a cubed plus 2a squared plus a plus 3 divided by 4a plus 3 gave us 2a squared minus a plus 1. And you notice that we did not have a remainder. Now you can always check this by going through and doing the multiplication. So in this example, I'm going to do that just so we have one done to show that it works. I'm not going to do that from now on because it just takes too much time and space on the board to go through and redo the multiplication. But it's not a bad practice for you to do that to make sure that your answer is correct. Because if my answer is correct, then I should be able to take 4a plus 3 and multiply that by 2a squared minus a plus 1 and get back to the same thing. So I'm going to distribute. So 4a times 2a squared gives me 8a cubed. 4a times negative a gives me minus 4a squared. 4a times 1 gives me plus 4a. 3 times 2a squared gives me plus 6a squared. 3 times negative a gives me negative 3a. 3 times 1 gives me plus 3. And now if I combine like terms, I have 8a cubed minus 4a squared plus 6a squared gives me plus 2a squared. 4a minus 3a gives me plus a plus 3, which 8a squared plus 2a squared, 8a cubed plus 2a squared plus a plus 3, it worked. Right? Check, it worked. So you can always do that. You can multiply back through to make sure that your division turned out correct. So let's do another example of this. Remember, it's the same process as what you did for basic long division. And I know many of you did not like long division. I understand that. And I know also that some of you have been taught synthetic division. I'm going to ask that you do not use that. When you get into pre-calc, feel free to use that. I'm going to ask here that you use long division. I want to see that you can do the long division. And if you don't know what synthetic division is, you'll find out about that in pre-calc. Okay, so let's get another one here. So what if we have, and I'm just going to write this out as the division already, 2x cubed minus 3x squared plus 10x minus 7 divided by 2x minus 3. And actually, let me modify this just because. Okay? So I'm actually going to erase that. I'm going to rewrite it. I know that may be a little frustrating, but I want to demonstrate something else while I'm doing this. So we're going to say 2x cubed minus 3x squared minus 7 divided by 2x minus 3. Now you'll see in a moment why I chose to do that. So 2x cubed minus 3x squared minus 7 divided by 2x minus 3. Now when we go to turn this into the long division, we have 2x cubed, that's supposed to be a cube, minus 3x squared. Notice that we don't have an x term. And we want to line up these terms. So this needs to include all degrees going down to a degree of 0. So if you're missing a term, you're going to have to add it in. Well, if it doesn't exist, that means you don't have any of them, or you have 0 of them. So plus 0x minus 7. So this is why I chose to do that. I wanted to get rid of that. So we have to fill this 0. If we do not put 0x in there, it's going to throw off our columns and our answer is going to come out wrong. Just like if you were to ignore a 0 in a division. If you had 1607 divided by 3, and you said, I don't need that 0, obviously that just changed the division. And that's exactly what it would do here. So you can think of each of these terms in a polynomial like a digit when you're dealing with long division. And you've got to have that digit there even if it happens to be a 0. So it may not show up here, but you've got to do it. Same thing here if you're dividing by a quadratic, 2x squared minus 3, 2x squared plus 0x minus 3. So make sure you have each of those. Once you start with a degree, make sure they all exist down to that x to the 0. So we're dividing by 2x minus 3. So that's very important. So now let's go through and see what happens. So how many times does 2x go into 2x cubed, or what do I need to multiply 2x by to get 2x cubed? I need to multiply it by x squared. x squared times 2x gives me 2x cubed. X squared times negative 3 gives me negative 3x squared. We subtract. 2x cubed minus 2x cubed gives me 0. Negative 3x squared minus negative 3x squared, or negative 3x squared plus 3x squared gives me 0. Which brings down, and then I bring down a 0, so I have 0x squared, right? Then I have plus 0x. How many times does 2x go into 0x squared? Well, it doesn't, so plus 0x. So I'm going to bring down which 0x times this will give me 0x squared. 0x times negative 3 gives me plus 0x. We subtract, we have 0x, and then we have minus 7. And this comes out a little interesting, because how many times does 2x go into 0x? It does not. Plus 0. 0 times 2x gives me 0x. 0 times negative 3 gives me 0. So let me put my subtraction off to the side a little more. 0x minus 0x gives me 0x. Negative 7 minus 0 gives me negative 7. So now I have a remainder of negative 7, so I have minus 7 over 2x minus 3. And now I can simplify it and say, well, these didn't really do anything for me. So I end up with x squared minus 7 over 2x minus 3. So we've got to remember to put in any spacers as necessary to make sure that we don't get thrown off in how we do it. In this particular case, it wouldn't have made much difference, but it still showed the process of doing that. Now I want to do one more. I want to go back into that one that we were just about to look at. Maybe just so we don't end on an ugly one like that. And let's go back to this 2x cubed minus 3x squared plus 10x minus 7 divided by 2x minus 3. Now obviously some of the things that we just saw happen are still going to occur. How many times does 2x go into 2x cubed? It goes in x squared. X squared times 2x gives me 2x cubed. X squared times negative 3x gives me negative 3x squared. When we subtract 0, 0, so we get 0x squared. We bring down that plus 2x, sorry, plus 10x. How many times does 2x go into 0x squared? It doesn't, so we have plus 0x, which is going to give us 0x squared plus 0x. We subtract and we get 10x, bring down the negative 7. How many times does 2x go into 10x? 5 times. 5 times 2x is 10x. 5 times negative 3 is negative 15. When we subtract 10x minus 10x gives us 0. Negative 7 minus negative 15, or negative 7 plus 15 gives me positive 8. So that gives me 8. We have nothing else to bring down. So plus 8 over 2x minus 3. And then we can simplify by getting rid of this 0x. And we can say that we have x squared plus 5 plus 8 over 2x minus 3. So long division of polynomials. Now realize with this, that's long division of polynomials, but there is another thing that we can do with this, and you'll probably wish that I covered this first, but you should already be familiar with this, is if we're dividing by a monomial. Dividing by a monomial, we can kind of get away with doing some other things. It's just some cancellation. So what if I have 24x cubed plus 30x squared minus 12x plus 18? And actually, let's just leave it as 12x. And I say to divide this by 6x. Well, here we should realize that, well, if I'm going to divide this by 6x, 6x is a common factor of 24x cubed, 30x squared, and negative 12x. So I can actually divide term by term. So instead of doing this, I can really say 24x cubed plus 30x squared minus 12x divided by 6x, which I could say is 24x cubed over 6x plus 30x squared over 6x minus 12x over 6x. And then I go, oh, well, 24 divided by 6 is 4. X cubed divided by x is x squared. 30 divided by 6 is 5. X squared divided by x is x. And 12 divided by 6 is 2. X divided by x is 1. And I have 4x squared plus 5x minus 2. So how's that for ending on a happy note? That if you're dividing a polynomial by a monomial, and each of those terms is divisible by that monomial, then you can just divide it term by term and get your final result.